So today, we're going to talk about a pretty different way of looking at software development. We're aiming for something that, let's be honest, feels a bit like the Holy Grail. Results that are actually predictable and controllable.
Okay, let's kick things off with a problem that I'm sure hits home for pretty much every developer out there. You know that frustrating feeling? When a perfect, brilliant idea on a whiteboard somehow gets twisted into buggy, fragile code by the time it's done? Yeah, that.
All right, so let's really dive into this gap, right? The gap between the big idea and what actually ends up in the code. This is, a huge challenge in software pretty much everywhere.
You know the drill. On one side, you've got that elegant concept on the whiteboard. It's clean, it's simple, it makes perfect sense. But then, you get to the reality in the code, and things get messy. It becomes ambiguous, buggy, and just fragile. This is exactly where bugs sneak in, and where maintenance becomes a total nightmare.
But what if? What if you could actually solve that? I mean, really solve it. Imagine having a link between your design and your code that's seamless, that's continuous, keeping everything perfectly in sync. That's a pretty bold claim, right? And it's right at the core of the Eiffel approach.
And look, I know what you might be thinking. Another new tool, another trend, but no, this is different. This is a whole philosophy, and it's all about prevention. It's rooted in decades of serious computer science theory.
This whole thing started way back in 1985. Dr. Bertrand Meyer, who's a huge name in object-oriented theory, founded Eiffel Software. And his vision was simple but radical. What if reliability wasn't something you test for after you code? What if it was just built into the language itself?
So the goal was to hit the big problems, the really hard stuff, right from the get-go. We're not just talking about finding bugs, we're talking about preventing them before you even write them, and maximizing code reuse, making testing way more efficient, and building robust parallel computing right into the design.
Okay, so that's the big idea. But how does it actually work? How do you enforce this philosophy in the code? Well, it all comes down to these 6 interconnected pillars that make the whole thing possible.
And the key thing to get here is that these aren't just 6 random features. No, they're all connected. They work together as a single, tightly integrated system. From the enforceable rules of design by contract all the way to the safety of parallel programming, each one builds on the others to create software that's provably correct.
Let's start with a big one, design by contract. This is really the foundation of everything. And it's not just about writing comments saying what your code should do. No, this is about writing rules that are actually enforced by the compiler, what the code needs, what it guarantees, and what has to be true at all times.
All right, pillar number 2. This one tackles a bug that I'm sure has caused every single one of us a headache, the null pointer error. You know, the one its own inventor famously called his billion-dollar mistake? Well, Eiffel's void safety system is designed to completely wipe out that entire class of errors.
And this is where we get to a claim that sounds almost impossible. But because of these incredibly rigorous checks at compile time, the system can make a promise that honestly changes the whole game when it comes to shipping code.
Just let that sink in. If your code compiles, you are guaranteed to not have a null pointer exception in production, period. That's not hope. That's not we tested it a lot. That's certainty. That's a level of determinism that most languages can only dream of.
Okay, so that's the theory. It sounds amazing, right? But what does this actually feel like for a developer who's in the trenches, writing code day in and day out?
We'll listen to this from one developer. He says the clarity is just off the charts. And then he says this, which is just wow. I cannot recall the last time I used a text search to locate properties or methods. Seriously, can you even imagine working like that? No more hunting around.
And here's another one from a team lead. He basically says, the compiler becomes your partner, your guarantor of stability. That's where this whole idea that the compiler is your friend really comes to life. If it compiles, it's solid. So here's the bottom line, right? Most compilers are like a grammar checker for your code. They make sure you put the commas and semicolons in the right place. The Eiffel compiler, though, it's more like a fact checker and a logic editor all rolled into one. It's checking what you're saying, not just how you're saying it.
And you might be thinking, okay, this sounds cool, but is it just some academic project? Not at all. This is a full-blown, mature ecosystem built for projects where you absolutely cannot afford to fail.
And when I say ecosystem, I mean it. It's not just the IDE, Eiffel Studio. You've got the whole package: consulting, custom development, enterprise-level support, professional training. everything you'd need to actually succeed with this on a real-world project.
And this isn't just them saying they're great. This stuff is officially standardized. We're talking ECMA and ISO standards. That's a huge deal. It means this is built to last, documented, and stable, especially for those big, mission-critical systems.
So when you pull it all together, what you're really looking at is a massive shift in how you think about development. Instead of that classic and, let's be honest, painful cycle of code, test, fix, you move to a world where you design for correctness right from the very start.
So I want to leave you with this question. Just think about it for a second. If you had this level of certainty, this actual contract, enforced by your compiler, how would that change your daily life as a developer? Think about the stress, the deadlines. What's that kind of confidence really worth, especially on that nerve-wracking day when you're about to push to production?